So let's evaluate functions. So given f of x equals -1/2 times x minus 4, find the range. So find the y value when the domain, the x value, is 6, 8, 10. So we have f of 6 equals -1/2 of x minus 4. So I'm seeing a lot of people who think this is a part of the equation. This is not. All that's doing is saying that we are plugging 6 in everywhere there is an x. So we're not adding that into the equation. We're just plugging 6 in for x. So we can ignore this entire side. That's going to stay the same no matter what. All we're doing is plugging 6 in where we see x. So x is the input, so we're putting 6 in for the input. And we want to see what does this equal when this is 6. So when x is 6, what is the y that goes with it? So we have -1/2, and you'll notice the 6 replaced the x. So I'm going to replace x with 6. And because these two are touching, I know they're being multiplied. So -1/2 times +6, and then bring down -4. Notice I'm not doing anything with this side at all. I'm only plugging it in over here. So now I can simplify. I know, so let's go in order of PEMDAS. So parentheses, so I see 6 and -1/2 are being multiplied. I want to deal with whatever's being multiplied first. So -1/2 times 6, a negative times a positive is going to give me a negative, and 1/2 of 6 is 3. And then I bring down the rest. So -4, and then I can simplify. So -3 minus 4. So some people get confused a little bit when it comes time to add and subtract negative numbers. So let's say you're at -3. If I'm subtracting 4, that means I'm going to keep going in this direction. And remember that as we go left, the number looks bigger, but it's actually a smaller number. So 1, 2, 3, 4 would give me -7. So when x is 6, the y that goes with it, the output, is -7. So I'm going to remember that. Okay. So the next one I'm going to plug in is 8. I'm using the same exact equation, but this time I'm going to plug in 8 for the x value. So you see it's asking me, when I plug in this number, what happens to this value? What's the output that comes out of it? So if I plug in 8 for x, I'll get -1/2 times 8 minus 4. -1/2 times 8 gives me -4 minus 4. So if I were to subtract 4 from -4, I'm going to get an even bigger negative number. So I'm going to get -8. So f of 8 equals -8. And then it says when I plug in 10 for x, it wants me to find out when I input 10, what is going to come out of that. So f of 10 equals -1/2. Plug in 10 for the x's. So I get -1/2 times 10 minus 4. So -1/2 times 10 is going to give me a negative times a positive is negative. 1/2 times 10 is 5. Then bring down the rest. So -5 plus -4 is going to give me -9. Or -5 minus 4 gives me -9. So f of 10 equals -9. So since the domain is written in these brackets, 6, 8, and 10, I'm going to write the range in the same way, using the numbers I just got. So 6 goes with -7. 8 goes with -8. And 10 goes with -9. So I read this as when x, when the domain is 6, the range is going to be -7. When the domain is 8, the range is going to be -8. When the domain is 10, the range is going to be -9. So this is how you would write the final range. So if you have a domain like this, you'll find a range like this by plugging in these values and seeing what happens to the equation. Notice I didn't do anything with the left sides. All I'm doing is filling in these equations. Let's move to the next problem. So given f of x equals 3x plus 5, find the domain. So it wants me to find the x value. And when I'm finding the x value, that means I'm solving for x. And we remember how to solve equations like that. When the range is 5, 8, and 11. So the range are the y values. F of x is the same thing as y. Y is the output, this is the output. So I'm going to replace f of x with these values. So f of x equals 3x plus 5 is the same thing as y equals 3x plus 5. So now I'm going to plug in these numbers for y because the range is 5, 8, and 11. So for the y value, I'm going to plug in each of these numbers and solve for x. So I'm going to plug in 5 for y. And remember, whenever you're solving these multi-step equations, we want to get rid of anything. We want to get the variable that we're solving for, which is x, by itself. So we have to get rid of anything being added or subtracted first, and then we have to get rid of coefficients. So positive 5 is being added to 3x. So to get rid of positive 5, I would subtract 5 on both sides. So then I'm left with 0 equals 3x. Then I'm going to divide by the coefficient. But I have to do it to both sides. So 0 divided by 3 is 0. So x is 0. So when the domain is, or when the range is 5, my domain, my x value is 0. Let's do it again this time. We're going to plug in 8 for f of x. So the f of x, remember, is the same thing as y. So it's saying the output of x, the function of x. So f of x. So I'm going to replace that with a y equals, and then 3x plus 5. And then I'm going to plug it in for my next value, so 8. So I'm going to replace, because this is the y values, I'm going to replace y with the second one because I want to see what happens. So you notice this is saying solve for x when y is this. So when y is 8, I'm solving for x. So whenever we have a multi-step equation like this, we want to get x by itself by getting rid of anything that's being added or subtracted, and then getting rid of any coefficients. So I'm going to subtract 5 on both sides because we believe in justice, and I'll have 3 equals 3x. So I'm going to divide by the coefficient now, which is 3, but we do that to both sides. 3 divided by 3 is 1, and then I finally have x by itself. So far I know that when y is 5, x is 0. When y is 8, x is 1. So notice we're matching it up. So when the y value is 5, the x value is 0. When the y value is 8, the x value is 1. So now let's find it when the y value is 11. So we have 11 equals 3x plus 5. So I'm going to start off by getting rid of anything being added or subtracted. Notice we're doing the same step in all of these. So 11 minus 5 is going to give me 6 equals 3x. Divide by my coefficient 3 on both sides. 6 divided by 3 is 2, and I get x by itself. So when y equals 5, x equals 8. When y equals 8, x equals 1, and when y equals 11, x equals 2. So this is our domain. So now we'll move to the next page in the notebook. So now it wants us to find the range of f of x equals 2x minus 4 when the domain is 1, 3, and 5. So it wants us to find the y values when the x value, I'll just say r. So when the x values are 1, 3, and 5, it wants me to find the y values that come with it. So I'm going to replace x, because remember, f of x is basically the y. So I'm going to replace f of x with y equals, and now I replace x with 1, 3, and 5. So y equals 2 times, and then I'm going to use 1 first, so 1. And go ahead and finish this one. Press play when you're ready to see the answer. Okay, so we're going to first distribute. So we have y equals 2 times 1 is 2 minus 4. 2 minus 4 is going to give me negative 2. So when x is 1, the y value that goes with it is negative 2. Now let's do the next one. So 3, I'm going to plug in 3 for x. So if I have y equals 2x minus 4, I'm going to plug in 3 for x. So 2. So first I'm going to distribute. 2 times 3 gives me 6 minus 4. So I'm left with y equals 6 minus 4. 6 minus 4 is 2. So when x is 3, when I plug in x for 3, the output, which is the same thing as f of x, is going to be positive 2. And then my last one is when x is 5, what is the y value that goes with it? So f of 5 equals So I'm going to plug in 5 for x. So 2 times 5 gives me 10 minus 4. 10 minus 4 is 6. So f of 5 equals 6. So this is saying when x is 5, the output is 6. So y is 6. So when x is 5, y is 6. So my range is negative 2 to 6. Now we have if f of x equals 3x minus 1 and g of x equals negative 2x plus 4. Remember, both of these are basically y, but these are the names of the function. So f is the name of this function, g is the name of this function. So it wants us to find f of 2. So we're going to use the function named f. So I'm going to plug in 2 for my x values. So I have f of 2 equals 3, and then I see an x right here, so I'm going to plug in 2 minus 1. And then I'm ready to solve. So 3 times 2 gives me 6 minus 1 equals 6 minus 1 equals 5. So f of 2 equals 5. Then we have g of negative 1. So I'm going to use the function named g. So g of x equals negative 2x plus 4. So I'm going to plug in negative 1 where there's an x. So see how negative 1 replaced x? That means it wants us to replace x with a negative 1 in the actual equation. So negative 2, then I see x, so times negative 1, plus 4. So I'm going to multiply. So negative 2 times negative 1 gives me positive 2 plus 4. 2 plus 4 gives me 6. So g of negative 1 equals 6. Then we add a little bit of difficulty to it. So we're adding a next step. So it's saying when it wants me to solve for f of 3, so find this answer, and then it wants me to add it to this answer. So I'm gonna do two equations at once. So f of 3, so I'm gonna plug in 3 over here. So 3x minus 1. So 3x minus 1, plug in 3 for the x. So 3 times 3 is 9, minus 1 is going to give me 8. So notice in this one, I didn't even write down f of 3. I only wrote down what the expression was. That helps me not get confused when it comes to the variables and stuff. So all you're worried about is this and plugging in what number it gave you for that value. So we have f of 3 equals 8. And then I'm going to add that to what g of 4 equals. So g of 4, so I'm going to write the equation. So negative 2x plus 4. So I'm going to plug in 4 for x. So negative 2 times 4 plus 4. Negative 2 times positive 4 is going to give me negative times a positive is negative 8 plus 4. Negative 8 plus 4 is going to give me negative 4. So g of 4 equals negative 4. So now I'm going to add these two together. So 8 plus negative 4 is the same thing as 8 minus 4. 8 minus 4 is 4. So f3 plus g4 equals 4. Let's do that one more time. I want you to press pause and go ahead and solve this one. So evaluate for f of 1 and g of 1 and then add them together, and then press play when you're ready. Go ahead and pause. So we have f of x equals 3x minus 1. It wants me to evaluate when x is 1 for the f function. So f of 1 equals, and then I'm going to replace my x with 1. So 3 times 1, and then minus 1. Then I'm going to solve. So 3 times 1 gives me 3. Bring down the minus 1. 3 minus 1 is 2. So f of 1 equals 2. Now I have g of x. It wants me to also use 1. So it wants me to plug in 1 wherever I see an x. So I have negative 2 times 1 plus 4. So negative 2 times positive 1 is going to give me negative 2, and then I add 4. Negative 2 plus 4 is going to give me positive 2. So g of 1 equals positive 2. And so now f of 1 is 2 plus g of 1 is 2. So it wants me to add those two together. So 2 plus 2 is going to give me 4. So f of 1 plus g of 1 equals 4. So sometimes we'll be given a problem like this, where it lists out the domain and range. So remember, domain are going to be all of your x values. So I always like to underline my x values because looking at long numbers like this can sometimes be confusing. So let me go ahead and underline all of my x values. So I underline all of my x values. So f of x is y. Inside of the x, so inside the parentheses, that is your x value. So it's saying find f of x, so find y when x is 0. That's how you read this. So when x is 0, what is the y that goes with it? I see 0 is right here as x. X is 0. The y that goes with it is 4. Find f of 3. So when x is 3, what is the y? When x is 3, the y value is 10. And now it wants us to find x when the f of x equals 6. And remember, f of x is just a fancy way of saying y. So find x when y is 6. So when my y value, the one that's not underlined, is 6. So when y is 6, x is 1.